Every frequency the universe speaks in has a purpose. Some are born from collapsing stars, others from the slow breath of hydrogen drifting between galaxies. Yet between those endless murmurs lies a line so precise it almost feels deliberate. A line where physics ends and intention begins. When that line flickered one night, no observatory noticed, no alert was issued. Only a single amateur astronomer surrounded by cables and static saw the rhythm hidden inside the noise. And from that moment, the question ceased to be, "What's out there?" and became, "Why did it choose to be heard?" The signal at 14 to 20. In the early hours of Coordinated Universal Time, a narrow spike rose out of the static inside an Ohio basement. The operator, a seasoned amateur astronomer with years of hydrogen line observations behind him, had been calibrating his software-defined radio when a thin, needle-sharp line appeared on his waterfall display at exactly 1420.40575 MHz. The shape was unnaturally clean, too symmetrical to be random noise. For several seconds, he assumed it was an artifact of equipment drift. But when he adjusted gain, swapped the coax cables, and recentered the spectrum, the line did not move. It held fast, unshaken by every control adjustment. His antenna was aimed 40 degrees northeast, elevation 61 degrees, coordinates that intersected perfectly with the position of the Andromeda galaxy at that moment in the night sky. The hydrogen line is an astronomer's safe zone. It is the one region of the spectrum intentionally kept free of artificial transmission, monitored only by those searching for distant quasars, nebular emissions, or perhaps the faint murmur of another civilization. Any narrowband activity there immediately draws attention because nature rarely produces such precision. The Ohio operator knew this, and the realization settled uneasily over him as he stared at the frozen trace on his screen. Every plausible source of interference, local Wi-Fi leakage, radar spillover, satellite reflections, was inconsistent with the purity of what he saw. The signal stability implied not just power, but intention. He opened his logbook and began to document everything: frequency, timestamp, atmospheric conditions, and system temperature. Then, hesitating only once, he posted a screenshot to the small Discord community of amateur observers who routinely shared detections of meteor scatter and hydrogen cloud drifts. His caption was concise, clinical, and unaware of the weight it carried. Narrowband spike at 1420 MHz, stable, greater than 90 seconds, pointing at M31. Any confirmation? Within that single line lay the first step toward an event that would soon cross oceans, echoes across continents. 6 hours later, under the grey dawn of Berlin, another receiver captured the same anomaly. The operator there, a software developer who had converted his spare room into a laboratory of circuit boards and coiled cables, was running automated FFT sweeps when the algorithm flagged a frequency match. His signal recorded at 0817 UTC mirrored the Ohio trace with uncanny precision. Same center frequency, same spectral width, same gradual drift consistent with Andromeda's relative motion to Earth. At first, he suspected a replay artifact or an accidental data import from the Ohio user's feed, but cross-checking the raw IQ files proved they were independent. Two receivers continents apart had registered identical emissions from the same coordinates. The Discord thread erupted into activity. Screenshots and CSV logs filled the channel. Timestamps aligned within fractions of a second. The community had seen countless false alarms before. Tropospheric ducting, ionospheric bounces, low Earth satellites masquerading as cosmic phenomena. But this time, each dismissal failed to fit the evidence. The signal's narrowness was unnatural, the frequency too exact, the consistency too global. When the Melbourne operator joined several hours later, confirming a third detection as Andromeda rose above the southern horizon, the weight of coincidence collapsed. His modest setup, a 2M dish anchored behind a farm shed, was enough to catch the same whisper from space, faint but perfect. The trio began a coordinated review. They aligned their GPS-disciplined clocks, compared environmental telemetry, and eliminated every known terrestrial emission path. None explained a signal that drifted exactly as the galaxy's Doppler shift predicted. In less than a day, what started as a hobbyist's curiosity evolved into a synchronized cross-hemispheric detection. Every confirmation deepened the silence in the Discord chat. Enthusiasm gave way to the uneasy awareness that they had uncovered something neither accidental nor easily dismissed. For the first time, the hydrogen line, the universe's most trusted silence, had spoken back, and whatever had broken that quiet, it was still transmitting, a pattern that shouldn't exist. By the second day, the collective of amateur operators had transformed into an organized analytical network. Their shared spreadsheet, initially a jumble of timestamps and senior readings, now resembled a professional observatory log. Each confirmed detection included environmental data, antenna specifications, and system temperature readings. The evidence was now global. 12 separate confirmations across North America, Europe, and Australia, all matching within the same frequency band and following the same Doppler drift predicted for Andromeda's approach toward the Milky Way. The alignment was mathematically exact. If the detections were independent, then the source was undeniably astronomical in nature. Yet, natural sources rarely behave like this. Hydrogen clouds emit broad, noisy spectra. Pulsars flicker across bands, not narrow channels. Even mazes, the most coherent natural radio emitters known, display far wider spectral lines. What the group observed was impossibly thin, no wider than a human whisper. The precision suggested either an artificial origin or a level of astrophysical behavior not yet documented. For those involved, both explanations were equally unsettling. The first coordinated tests began that evening. The Ohio operator suggested reorienting one of the dishes 5 degrees off target to test for local interference. The spike vanished instantly, returning the moment Andromeda drifted back into the beam's path. This alone confirmed what everyone already feared. The emission came from the sky. It was no software glitch, no equipment malfunction. It was deliberate, persistent, and coordinated with celestial mechanics. As they layered their recordings and compensated for atmospheric noise, a faint rhythm began to emerge, a structured modulation just above the noise floor. It wasn't random static. The power varied cyclically, as if carrying information in amplitude or phase. Several members began decoding attempts, feeding the data through Fourier filters, deconvolution algorithms, and binary reconstruction scripts. By late night, the collective had achieved something no professional facility had yet done, a coherent, reproducible pattern extracted from the hydrogen silence, the numbers within the noise. It was the retired engineer from Ohio who first recognized the sequence. His small Python script, originally designed to flag repetitive signal bursts, counted precisely 1,679 distinct pulses before the pattern repeated. The number struck him immediately. It was the same product of primes used in the famous 1974 Arecibo message 23 multiplied by 73. A deliberate grid size chosen by human scientists to represent a binary image recognizable by any intelligent mind familiar with basic mathematics. Prime factors are universal. They announce intelligence through the language of logic itself. He posted his finding to the group, and within minutes multiple operators confirmed identical pulse counts. The Berlin developer, curious to see what would happen, mapped the data into a 23x73 binary array. The screen filled with a crude but striking image. On the left, a spiral shape coiled outward, unmistakably reminiscent of a galaxy's arm. Along the right edge, dots and short dashes formed distinct clusters, two ordered to be random. In the center, a tight knot of repeating marks suggested symmetry. Something constructed, not chaotic. Disbelief rippled through the group. Some suggested coincidence, others data corruption. But the statistical improbability of random noise forming such alignment was beyond dismissal. They began cross-referencing the sequence against known radio interference patterns, GPS chirps, telemetry bursts, ground radar echoes, but none fit. The modulation depth, repetition interval, and Doppler correction aligned exclusively with a distant, consistent source. For some, the revelation was thrilling. To others, it was unnerving. The last time humanity encoded those same prime factors into a transmission. It had been a greeting, a mathematical handshake to the stars. Yet now here it was reflected back, reinterpreted, rearranged, and sent from a place impossibly far beyond any known capability of life as we understand it. The binary array's meaning remained uncertain. Some saw the spiral as symbolic, a message identifying the sender's galaxy. Others saw something deeper, even recursive within the central cluster, as if the signal's content described not just its origin, but its method of creation. The hydrogen line, once trusted for its silence, now carried geometry. Numbers had become image, and image had become a question. Whatever was sending this signal wasn't just broadcasting, it was communicating the message in the map. As the data spread among the amateur community, new analyses began to surface. The 23 by 73 matrix was no longer a random grid. It was now a map of meaning, decoded line by line across screens from Berlin to Melbourne. The spiral form on the left was unmistakable. Its curvature too precise to be coincidental. It echoed the arms of a galaxy, but not exactly Andromeda or the Milky Way. It looked simplified, almost emblematic, as though it represented the concept of a spiral galaxy rather than a specific one. To its right, a column of short bursts and pauses fell into recognizable grouping. A chemical chart emerged from the noise. Atomic numbers corresponding to hydrogen, carbon, nitrogen, oxygen, and phosphorus. The 5 foundational elements of organic life. Those who saw it could not agree on what it meant. Was it a self-identification, a signal from life announcing shared chemistry? Or was it something older? A mathematical fingerprint left behind by a civilization long extinct. The deeper the operators analyzed, the more deliberate the message appeared. In the central region, a denser cluster of repeating marks defied randomness entirely. When the pulse intervals were translated into ratios, they matched the Fibonacci sequence, a natural mathematical pattern that appears in spiral galaxies, seashells, and even biological growth. Some argued it was a coincidence. Others saw it as proof of structure, an intentional bridge between mathematics and life. The Discord thread transformed into a virtual observatory. Each operator uploaded their data, their scripts, their visualizations. Code revisions were passed around like notes between laboratories. The language of mathematics had replaced conversation. Every new result deepened the unease. This was not noise, and it was not natural. The grid resembled an encoded statement, a compressed signature from across the void. The impossible transmission. The discovery forced the group to confront a larger, colder question. Could a signal from Andromeda even reach Earth? The gulf between galaxies is vast beyond intuition. Andromeda lies roughly 2.5 million light-years away, about 2.37 by 10 to the 22nd m at 1420 MHz. That distance translates into a free space path loss of nearly 486 dB. To put that in perspective, even the most powerful radar systems ever built on Earth would vanish into cosmic silence long before crossing a fraction of that span. For such a transmission to survive, it would require power levels on a stellar scale or precision beyond anything humanity could construct. In theory, a civilization capable of harnessing energy from an entire star, a Type II civilization on the Kardashev scale, could accomplish such a feat by focusing an immense beam through a planet-sized phased array. The power requirement could drop from quadrillions of gigawatts to thousands of megawatts. Still monumental, but physically conceivable. The beam would need accuracy within microarc seconds, holding Earth's position steady across the rotation of 2 galaxies, separated by time and gravitational drift. Even then, signal degradation from intergalactic plasma and cosmic background radiation would smear any ordinary broadcast into unrecognizable noise. Yet, here it was, a structured, stable transmission, coherent enough to carry information. The amateurs knew the odds were absurd. Yet, the mathematics refused to dismiss it. Please like and subscribe channel.